My name is Anton Antich. I am the co-founder and CEO of Integrail, the platform for building agentic AI applications without coding. So in this part, we will be looking at the increasingly more sophisticated agents, starting with introduction, through some fun, through discussing hype terms such as Retrieval Augmented Generation and vector memory. Then we will be building simple reflex agents with web search and email assistant functionality. Then we will look at stateful agents, adding memory, both long-term and short-term. And then we will discuss learning agents that are able to improve their performance and behavior. And finally, we will have a short session on how to deploy and do quality assurance using our platform. So let's start with introduction to the AI agents, and let's start with the simplest AI agent possible. So this is how we define an AI agent. This is not the simplest. This is the most complicated agent that we will be building at the end of our session, just to give you the picture towards what we are moving. So basically, what is an agent? An agent is an analogy. The easiest analogy is a human being. We are agents. We perceive the world through our eyes, our ears, and other senses. We process the world with our brains. And of course, we have memory, also roughly short-term and long-term. And then we have actuators, which are our hands, our feet, our mouth, with which we are able to affect some sort of change in the external world. So the same goes for AI agents.
Yeah, so Anton, I have a question. So your long-term memory, is that the same thing as what you mentioned as vector memory? It's pretty much
right.
So it's the vector database fully loaded in memory. So does
no, it's not. It's not loaded in memory. It's just a vector database that is available for agents that you're building.
Okay, so it's diskless then. Okay.
Yeah. Now we provide vector memory, but actually in the nearest future, on the roadmap, we will also include graph RAG as well, because there are some nice papers that came out recently that show that combining vector RAG and graph RAG that represents knowledge a little bit better, there are even better results. So this is something exciting that's coming out soon as well.
Right. I mean, considering you cannot have a lot of memory in a server, doesn't that kind of limit the size of your vector memory in a box?
No, not really, because again, the way agents work is that long-term memory is pretty much unlimited. It's limited just by the size of the physical database. But then, when an agent processes an interaction with a human or with external input, we load whatever is needed from long-term memory into short-term memory, and then we put it as part of the context to our LLM brain, so that it has only the relevant information. And that is also sort of a best practice of how to build this agent. So, continuing the analogy. Once again, the AI agents, they are pretty analogous to humans. They have sensors that allow them to understand user input and external systems, which is very important. We are able to read all kinds of external systems via API. Then we have memory, long-term memory we discussed. It's a vector database. You can build it as much as you want. Short-term memory is populated based on the sensor input and on the relevant information from long-term memory. Then we have a brain that we can build to...
So Anton, would you say short-term memory is effectively equivalent to a context with respect to LLM?
Yeah, it's just a context, basically, yeah. I mean, it's a bit more complicated because we can update it from session to session, but eventually it becomes part of the context.
And just so I'm clear, maybe I heard wrong. The long-term memory is a vector database, but it's sitting in memory?
No.
It's sitting on SSDs or disk or someplace else. So there's really no limitation to long-term memory other than storage class. And you're saying that you're doing like a vector search to bring in and create the context for the short-term memory.
Right.
Based on whatever the user input is or the external system.
Yeah, exactly. Right. Okay. So yeah, we have a brain that is based on LLMs primarily, but we can use other techniques as well. And then we have also a bunch of skills, and this is also an idea we got from a couple of research papers that works quite nicely. Basically, skills are specialized, simple agents that are able to do a certain task. And then by building a hierarchy of agents who can understand the user intent through intent detection, they can pick whatever skill to choose to execute the task. And then, of course, there are also actuators which are able to interact with the user, such as output text or output voice, or do some sort of change in the external system, such as send an email or update a CRM, etc., etc. So this is kind of the sophisticated agent that we will get to building in the end. But
so Anton, the business applications you were talking about, they would represent different skills in this framework?
Different skills, but again, it's let me just take a step back and tell you a little bit about what inspired me to do all that. I kind of mentioned it already, that I think that nobody really knows what the AI revolution will bring. People have different expectations, people have different prognoses, but I think that this is a wave that is probably bigger than the invention of the computer. We don't see it yet. But what I want to do and play my little part in it is to enable people around the world in companies or personalities to experiment, to build the agents, the AI agents that they can come up with. And we ourselves have lots of ideas. We were actually building the tool pretty much 24/7, so we didn't experiment with actual agents that much. We started already. We have a bunch of ideas. So we just want to see where it will take us, where people with their creativity, they will come, they will start building more complicated agents than just specific skill-based agents that can, update the CRM, provide a forecast, send an email, and then we will see where it gets us. But basically, the future is wide open. We just want to enable people's creativity and see what happens.
So, Anton, if I understand your theory correctly, in traditional no-code use cases, I can't build complex applications with traditional no-code systems. Traditional AI code assistants, I can't build complex applications to meet business processes with that. in each case, I need a developer who stitches all of this stuff together. So I might be accelerating my code development cycle, but I'm not displacing developers with that model. Your theory is basically if you build a basic building block of no code or low code, no code, augmented by AI agents, and with these skills and the ability to use different LLMs, this basic building block uses your platform to create multiple agents in a distributed system to build complicated applications.
Yes, that is part of it. Another part of it is that, and I think that's also one of the changes coming with AI that people do not fully realize, is that we only created applications because of how computers are architectured. So basically, when we talk about AI agents, we don't need to think about applications. We are basically creating a mini human. Of course, it's not really a human, not by a long shot, but still, it's something that is able to do tasks similar to human.
So if I'm thinking about this, let's compare it to robots instead.
Yeah.
So if I have a robot, if I have this skilled robot that can do a task, let's say send an email, I have a robot that can pick a part. If I have a robot that can do customer service interaction, if I take those three robots, combine those, mix and match those capabilities, I can create, kind of an infinite set of workflows from a business process perspective. And now I'm not building applications, but I'm taking agents to build complex automation that mimic what we use for applications.
Exactly, spot on. Yeah, that's sort of where we want to get to. All right, but so let's try to build the simplest possible agent. We forget about all the complications such as memory and context and everything. We just have user input, we have brain, and we have some sort of user output. And this is just for us to start getting a hands on the platform. And so let me just switch to the platform itself. Just 1 second. Yeah. All right. So once again, a caveat that public launch comes on September 17th. So some of this functionality may not be available currently, but it will be available definitely after September 17th. So this is the studio, how it looks like. Pretty easy interface. So the first page, you will see the featured agents. Now it's only 3, just as an example, but we plan to populate it with at least 20 of different featured agents with which you can interact via chat, or you can copy them and start building and use them as a template to learn. And this is actually also another very important part to our company. We are launching what we call Integrail AI University, where we will be educating how to build agents, because the area is just so big, it's so vast. And I mean, now we have 2 hours, and we will probably get tired of this discussion already, but we will barely cover, I don't know, 5% of what is possible, how to do actual stuff, because there are topics such as how to do correct prompt engineering, how to do RAG properly, etc., etc. So for all of those purposes, we are launching this university. We will be freely educating people on how to build agents for different tasks, again, in hopes to unleash the people's creativity. But also part of this education is providing these featured template agents with which you can chat, or you can copy them and start building from a template to see how it was built internally. So on the left, there are a bunch of different menus. We will spend most our time in the Agent Studio today. Agent Studio allows us to design the agents. So let's just go into the designer. So this is the template basically for the simplest agent. It's exactly what we have seen on the slides as well. There is user input, there is some processing, currently it's an LLM, and then there is user output. So, but let's just build it completely from scratch to show how easy it is, and again, to give you and anybody who is watching an idea of how to use the interface. So let's just make this area bigger. So here we have a library of different nodes that can be used when building an agent. We have nodes for all kinds of different purposes, to work with the vector memory, to work with sessions. We have different kinds of LLMs. We have text to image, image to text, different image manipulation, video creation, text to speech, speech to text, and then a bunch of external integrations which are constantly growing. So, but let's once again create the simplest possible agent, and that is just, we need a node that is called LLM Simple. So we just click on it. We can close this one. Then we simply connect user prompt to the user prompt, and then we connect output to output. So that's it. It's the basic, the most simple agent that we can create. On the right, when you click on every node, you have the settings for an actual node. So agent inputs, usually there is a user prompt, but you can build all kinds of different inputs as well, especially if you plan to use your agent via API. This will be quite useful. For LLM, we have a model, so we have lots of different models that we support. We have Llama, we have Google Gemini, we have OpenAI, we have Claude from Anthropic. So we can change them freely. And then, of course, there is user prompt, there is system prompt, where you can provide certain instructions. And that's it. Your agent is already functioning. So let's just save it. Let's go into agent settings, call it agent Save. And now we can, okay, what is 2 plus 2? This is the contents of our prompt. Let's just run it. So we can press this button, it runs, it shows you the time it takes, it shows you that it finished. Then we can go to the output and we can see that
So Anton, in this case, it's using the actual GPT-4o API available at OpenAI to do this. This is not doing anything on-prem or on your specific cloud.
No. Well, I mean, on our cloud, it runs the actual agent, which is the succession of different tasks that need to be executed. So to make it a little bit more interesting, because this agent is the most boring there is, let's just add one more node real quick. Let's add a text-to-voice node, text-to-speech. And then once again, you will see how easy it is to make manipulations here. So we drag from output here to input. We pick the voice format we can have as this, and then we drag output to the output. That's it. We just gave voice capabilities to our agent. Let's save it. We can run it here, but there is, as mentioned, a better way to interact with an agent when you have created it. And this is by going into the chat with agents tab. You will see all the kinds of different agents that you have. Then you can select it. We will see the response for the calculation we asked previously. But now let's ask it something else. But actually, let's go to a slightly different agent. It's the same one that just has something in the system prompt to make it a little bit more fun. So just say, "Hi, I'm back." It responds. So you see it's a little bit sarcastic, and then it actually generates voice.
Well, well, well. Look who decided to grace us with their presence. How have you been?
I'm not sure if you can hear it, because sometimes we don't play. Okay.
So where's the context associated with the chat that was being created through this agent?
No context yet. It's the simplest possible agent, has no context, no memory. We will get to those agents gradually. The idea behind this demo is to build more and more sophisticated agents step by step. So we're starting with the basic thing, no context at all, just a transaction. You write something, it responds. That's it. So just once again to get you familiar with how we do stuff here. So let's move to something a little bit more interesting and have a little bit of fun, and also illustrate the idea that you need normally a bunch of different specialized solutions to do a complex task. And we will build an agent quickly that does that. And this is somewhat of a contrived example. Nobody is going to use it in real life, of course, but again, to illustrate how it's possible. So we're going to build a lazy Instagram poster. So basically, I don't want to write Instagram posts, and I don't want to even shoot photos. I just want to write one sentence of my experience, like breakfast by Eiffel Tower. And then I want my agent to write a nice Instagram post and create a picture. So let's see how we can do that using Integrail Studio. So, okay, let's just take this agent as an example and continue working here. So what we want, once again, we want to write a simple sentence, and then we want one LLM to write an Instagram post. So we'll take the same LLM and we'll just say,
what's the token limit for chat GPT-4o? 128K.
Let's just say,
yeah.
No, it's Llama 3.1, but
please create a nice Instagram post based on the
Yeah, this 128.
right, at least paragraph. Share. So this is just the post writer, but we also want to make sure it generates a picture. So let's see how we build that. Once again, we go into our list of notes. We go into text to image. We take it here. Then we can also use a model. We have a bunch of text to image models. We'll use something that provides good images. Let's say it's Stable Diffusion 3. But now we are sort of faced with an issue, because if we just put one sentence such as breakfast by Eiffel Tower into the image generation, it won't produce a nice image. It will be quite boring. So we will illustrate a little bit, just a touch of functionality of how different LLMs work together to become much more powerful. So we will create another LLM here. Let's just go into another LLM, and we will ask it to take whatever post this has created and then create a nice image prompt based on it, because image prompt has to be somewhat different than just a simple sentence or than an Instagram post, because it's also not a very good not a very good image prompt.
Has begun.
So here we say, please use the Instagram post provided. Okay. Very good. Image generation from based on it. Make it photographic style. With the prompt here, we want to be a bit creative. So let's put temperature 0.7, and now let's connect also image generation here. Okay, let's test it. Let's go to user prompt, and once again, let's just, as we want to be lazy, let's write exactly that sentence. So breakfast by the Eiffel Tower, and press run. So we see that first we have our post generation thing working, then we have our converter, and then we have our image generator. We can check the status here as they work. Then we can see a nice Instagram post with icons and with hashtags, etc. Now let's wait a little bit.
So Anton, the reason you had two GPT-4o was you wanted to focus the second one on the image generation aspect?
Yes, exactly. We want to specialize them, and that's also the key to create good agents, because we have to have different LLMs working together.
Or different prompts at least, right?
This one has just created this nice post. This one takes this post and it converts it into a good description of an image. So it's a different thing, because if we feed it directly, the image quality will not be as nice. And as you can see, it's quite a nice picture. We can post it to Instagram. And then again, using our external APIs, we can actually add another box that will post it to Instagram, but we do it not to make it much junk there. And then, of course, you can also interact with this agent via chat interface. Again, we actually have a prepared, it's pretty much the same. It actually gets your mood quite nicely as well. So let's say, I don't know,
Doesn't look like perfect. More like
blue Valentine's.
So you could have created another one that did like an audio stream of the sounds of having breakfast by Eiffel Tower, if you wish.
Yeah. So yeah, as you can see, it just takes whatever I provide and it creates a nice experience based on that, and then there is an image generated. So,
Anton, a question about the process here. It still seems fairly linear. Is it capable of taking an an LLM or some model and having it then choose tools based on what it feels are appropriate actions to take, so it can actually feed back into itself? Like, is there a capability that feels more interesting than these kind of demos?
we can jump right to more complicated stuff if you guys like. I wanted to sort of build it up gradually because again, I think everybody has slightly different level of understanding. Okay, so that was a little fun. Now a little bit of commentary about RAG and why it's a big deal and why lots of startups and companies that are appearing actually using it. So I'm sure all of you know that if you talk to an LLM directly, it hallucinates, which means if it doesn't have the correct answer to whatever you're asking it, it will still provide an answer. It will invent it. And there is no way for you to know, and this is actually the sort of a trap a lot of people have stepped into. They interact with ChatGPT, and they have no idea whether the responses it provides are correct or not. So the way around it is the whole point about vector memory and RAG, which is Retrieval Augmented Generation, as we already discussed. So the idea is you provide some input. We search and we find semantically close context in whatever database we have that is semantically relevant to whatever a user is asking it for. And then we put it as part of the context that is invisible to the user, but it's visible to the LLM. If you do such a trick, then the responses it provides are accurate. It does not hallucinate. It just takes the relevant information. It understands, so to say, the user's request and is able to provide a good response. So RAG is a must-have for any good AI agent, and that is the functionality that we have out of box in Integrail. So let's have another real quick
So
demo.
Anton, is your vector database something you developed yourself or using something off the shelf or?
Yeah, we're using standard. We used a couple. Now we settled on Mongo, but we will see how it works going forward. Okay, so let's go back to the tool. So memory management is the third item here on the list. The interface will be changed. This is all hot off the press. We are a startup after all, as we said. We believe in this early release often and in the feedback. So we have different memory sets here. In the memory set, we have different items. I have added just two for the purposes of this demo. It's very easy to add new memory item by just clicking add new memory item. Then you can copy whatever piece of information you want, or you're also able to import files, which will be live by our official launch date, September 17th. So this way you can build different kinds of memory sets for different purposes.
When you say memory sets, you're really talking tables and or databases that can be selectively chosen to augment the context of a prompt?
Yes, correct. Yeah. So here it will just look as a separate box. So let's look at how to use the memory in the agent. So we can switch from our Instagram maker into demo number 3, which is simple RAG. So once again, let's not build it from scratch. I think everybody got the idea of getting the boxes or nodes from the list of nodes. So what we do here is, again, we have user input. It goes into vector search box first, and then only then it goes to the LLM. And then we provide very sort of lightweight system prompt where we say, use the following context when responding to the user. So if our vector search finds something, it will use it in creating the response. So to demonstrate how it works, let's just, again, go back to chat with agents. Let's go to our simplest agent, which has no vector memory. And let's ask it, who is Anton Antich, which is me. Let's see if it's able to say something. So as you can see, this is the typical hallucination. It has no idea who I am. So it says, you mean the guy who invented the words self-tying shoelaces. Nice joke, I appreciate it, but it has nothing correct. So let's move to this agent which we have just created with reg, simple agent reg. And we can ask who is Anton Antich, and one of the memory pieces was about me there. So as you can see, it provides a correct answer because it was able to find the relevant piece of context, put it in the context, and then provide an answer. Basics of RAG, which every agent that you use should use to be useful. So let's go back and again talk a little bit about the principle of how then again this great analogy with robots, right? So that's exactly kind of our vision. There are two ways for you to create a really cool AI or a team of AI for yourself or for your company. And the two ways are building different memory sets, because again, LLMs are not trained on your proprietary data. They don't know unknown people such as myself. So you can have specialized memory sets with different type of data, like corporate proprietary knowledge. We can import all of your corporate database into our vector database, and automatically all the agents you are building will be able to use your corporate knowledge. This is, of course, something we are eating our dog food. We are creating that at Integrail right now. Another database may be my personal interests. I am browsing the web, I take a link, I put it to an agent and ask it to put into our memory, our joint memory. It reads it, summarizes, puts into memory, then I can talk to this agent about something that interests me, about current events, about papers I read, about news in astronomy or whatever, depending on your interests or hobbies. I can put code for various projects there. To the question of them producing code, yes, like from the head, they probably won't provide the right code in many cases. But once again, if you use the RAG trick, if you put the code that you already have in your project as part of vector memory and then use it as context when interacting with your programming assistant, it will provide much better code that is you're able to use in your applications. Then there is also like vertical systems knowledge. This is another important point. Oops, what's happening? Yeah. Basically, it allows us to create agents that understand, for instance, what CRM, this customer relationship management system, because it is very complicated. Many people have tried to create a generic web agent that will just fulfill any tasks on the web. That's pretty much impossible. But if you provide them with vertical knowledge, then they become much more productive, much more accurate. So we can create a vertical knowledge about what CRM is, and we can create an agent that uses this knowledge, and that will be able to do much more complicated tasks for us than just a generic agent. So one part of building our sort of super cool AI that is my AI that knows me, my preferences, or my corporation, and then my proprietary knowledge is by building up these memory banks. Another one is, of course, building these teams of agents, as we discussed. And this is where it will be kind of a crowd effort, because, of course, we will be building lots of basic skill-based agents for people to use. But then, as people use Integrail and build their own agents, if they want to make them available for others, we welcome them to do so. This way, there will be a huge library of skill-based agents that are able to interact with your knowledge, which nobody else has, and this way be useful for you. So this is sort of the strategic approach in how to build the agents, and this is the journey we are just starting ourselves, and we invite anybody who's interested to do that as well. So this is it for the introductory part for simple AI agents. Once again, AI agents are like humans. They have sensors, they have memory, they have brain, they have actuators or hands. Agentic AI, it's where we work with teams of agents working together. And retrieval augmented generation or vector memory is key to provide good quality results. Now let's build these three types of agents that are classic from any AI book that you can read. There's been research going on for 50 years. Basically, we start with very simple reflex agents, which are simple transaction agents. You do something, or they sense the environment, and then they do something else in the environment. Then we move to the state agents, which everybody is asking for, and quite understandably, which are able to update the state from interaction to interaction. And then finally, we will discuss learning agents a little bit.
So, Anton, as you go through this session, it would be really interesting to see, especially as we think about sensors and actuators. There are things that LLMs are very, very good at, and there's things that they're not very good at, i.e., creating a chart with accurate data or building something like a yard sign. It's very good at the design, but it's not very good at the details. So there's need, like most low code or no code systems, there's need to actually give it to a system that it can actually do something consistently. And with like hard math, etc., can you show during this session how you would hand that the role of an agent off to a much more capable platform, or building that platform using this system?
Yeah, I'll make an effort. Some of these are still for us again in development. We do want to
even the idea of it, like your vision. If it's not there yet, that's fine. Just the vision of how do you hand it off to. I'm sitting here next to my good friend that's a Python developer, and I want to be able to hand it off to him and say, "Well, finish this off for me."
Okay.